Have you ever wondered how computers understand the programs we write, or how we are able to communicate complex ideas through language? In our daily lives, we unknowingly use various formal languages, essential tools that allow us to structure and share information. Within the world of computer science and linguistics, these formal languages take different forms, each with its unique characteristics. One such type is the context-free languages. Now, when you hear context-free, you might think, what's that? Well, you've come to the right place. Today, we'll delve into the realm of context-free languages, exploring what they are, how they're used, and why they're so crucial in our day-to-day communications and in the intricate world of programming. So are you ready to embark on this linguistic journey? Stick around to uncover the mysteries of context-free languages and their importance. Context-free languages, despite the complicated name, are actually quite simple to understand. Imagine you're cooking your favorite meal. You have a recipe that tells you exactly what ingredients to use, in what order to add them, and how long to cook everything. This recipe is a set of rules that you follow to create a delicious dish. Now, let's take this cooking analogy and apply it to computer science. In the world of computer science, a context-free language, or CFL, is like that recipe. Instead of ingredients, you have symbols. Instead of cooking steps, you have rules on how to put these symbols together. Just like how a recipe can create a variety of dishes, a CFL can generate a variety of strings of symbols, forming different sentences or expressions. But where do these rules come from? Well, they come from a context-free grammar, or CFG. A CFG is like the cookbook that holds the recipe. It provides the rules on how to arrange the symbols, just like how a cookbook provides recipes on how to cook different dishes. Now, you might be wondering, what's the deal with the term context-free? It means that the rules of the grammar apply regardless of the wider context. For example, in a recipe, the step add 2 teaspoons of sugar doesn't change, no matter what other ingredients are in the bowl. Similarly, in a CFL, the rules for how to arrange symbols remain the same, regardless of what other symbols are present. Let's also mention the pushdown automaton, or PDA. This is like a chef who can follow the recipe. A PDA can recognize whether a given string of symbols follows the rules of the CFG, just like a chef can tell if a dish was cooked according to the recipe. So in essence, a context-free language is a set of rules, like a recipe, that can generate or recognize certain patterns. Now that we've grasped what context-free languages are, let's look at some examples. First up, we have the language defined by the rule a to the power of n, followed by b to the power of n, where n is a non-negative integer. Now that's a bit of a mouthful, isn't it? But don't worry, it's simpler than it sounds. Basically, this language consists of strings of a's followed by an equal number of b's. So AB, for instance, would not belong to this language because it has 3 a's and only 2 b's. But ABB with 2 a's and 2 b's would fit the bill perfectly. This is a clear example of a context-free language because the grammar used to generate it doesn't depend on any context. Next up, we have arithmetic expressions with balanced parentheses. For instance, the expression 2 times 3 plus 4 is a valid member of this language. The parentheses here are balanced because every opening parenthesis has a corresponding closing one. Again, the grammar used to generate these expressions is context-free because it doesn't rely on any context. Moving on, we come to the syntax of most programming languages, such as C, Java, or Python. The syntax rules of these languages can be described using context-free grammars. For example, in Python, a simple if-else statement follows a specific structure that can be described using a context-free grammar. The structure doesn't change based on the context. Hence, the syntax of Python and most other programming languages is context-free. Finally, we have natural language sentences. Now, this is a bit tricky. While natural languages like English, Spanish, or Mandarin are not strictly context-free due to certain complex phenomena, context-free grammars are often used as approximations for certain aspects of their syntax. For example, a simple English sentence follows the structure of subject-verb-object. John eats apples, cats chase mice. These sentences follow this structure regardless of the context. So in a way, this aspect of natural language syntax can be approximated using context-free grammars. And there you have it, 4 diverse examples of context-free languages, each one demonstrating a different aspect of these fascinating languages. Whether it's a simple string of A's and B's, an arithmetic expression, the syntax of a programming language, or the structure of a natural language sentence, context-free languages are everywhere. As you can see, context-free languages are all around us, from the programs we write to the languages we speak. You might be wondering, why do we need to learn about context-free languages? This question is more than valid, and the answer is quite fascinating as well. Context-free languages, or CFLs, play a crucial role in computer science and linguistics, areas that are deeply interwoven into our daily lives. Let's start with computer science. Ever wondered how your favorite apps and software are built? They are crafted meticulously using programming languages. The syntax of most of these languages, like Python, C, or Java, is context-free. Context-free grammars, the generators of CFLs, are used to describe the syntax rules of these languages. They provide a structured way to write code, which is then processed by compilers or interpreters. This ensures your programs run smoothly and as intended. But that's not all. CFLs are also instrumental in natural language processing, a subfield of artificial intelligence that focuses on the interaction between computers and humans. When Siri, Alexa, or Google Assistant understands your commands, it's because they are using principles derived from context-free languages. They help form the basis for parsing sentences and understanding the structure of human languages, enabling your devices to communicate with you effectively. Now, let's turn to linguistics. While natural languages aren't strictly context-free due to complexities such as agreement, long-distance dependencies, and ambiguity, context-free grammars are often used as approximations for certain aspects of natural language syntax. They help describe many syntactic structures in natural languages, allowing us to analyze and understand the intricacies of language better. So you see, context-free languages are not just abstract concepts confined to textbooks. They are fundamental tools that help us design compilers, facilitate natural language processing, and parse sentences in both programming and human languages. They provide a formal framework for describing and analyzing the structure of various types of languages, and are essential tools in theoretical computer science and computational linguistics. So, the knowledge of context-free languages is not just theoretical, it has practical applications that we encounter every day. We've come a long way in understanding context-free languages. Let's take a moment to reflect on our journey. We started by defining context-free languages, a type of formal language that can be generated by a context-free grammar or recognized by a pushdown automaton. These languages are not just theoretical constructs, but they are fundamental tools in computer science and linguistics. We then explored a variety of examples that brought the concept of context-free languages to life. Remember the language consisting of strings of the form an, bn, where an is a non-negative integer, or the language of arithmetic expressions with balanced parentheses. These examples illustrated how context-free languages can describe a wide range of structures and patterns. But perhaps the most fascinating examples were the ones drawn from our everyday life, the syntax of programming languages and aspects of natural language sentences. It's amazing to think that every time we write a line of code in Python or Java, or even when we construct a sentence in our day-to-day conversations, we're interacting with context-free languages. And finally, we delved into the importance of these languages. They are not just academic curiosities. Rather, they provide a formal framework for describing and analyzing the structure of various types of languages. Whether it's designing a compiler, building a natural language processing application, or parsing a complex document, context-free languages play a crucial role. So what's the takeaway? Context-free languages, though they may seem abstract and complex, are integral to how we communicate and process information, be it in human languages or programming languages. They are like invisible threads weaving through the fabric of our digital lives, shaping how we understand and interact with the world. So the next time you write a program or read a sentence, remember the context-free languages working behind the scenes. Until next time, keep exploring and keep learning.